All right, let's talk about balancing chemical equations and the things necessary in order to be successful at this. So to begin with, we need to understand the reason for balancing chemical equations. Look at this first equation right here. We have 4 phosphorus at the beginning, 4 phosphorus atoms at the end. Cool. Here we have 2 oxygen atoms at the beginning and 10 at the end. This violates the law of conservation of mass. If you start with 2 oxygen atoms, you should end with 2 oxygen atoms. Effectively, this is saying that 8 appeared out of nowhere to turn 2 into 10, and we can't do that. What we can do, though, is say, if I had 10 oxygen atoms here at the end, I must have started with 10 at the beginning. How do I make 10? I put a 5 here, this coefficient 5. What this is telling me is that I have 5 O2 atoms in order to turn this into an equation that makes sense. Now I've got 4 phosphoruses at the beginning, 4 at the end. 5 times 2 equals 10 oxygen at the beginning and 10 at the end, which satisfies the law of conservation of mass. Think of it as being roughly similar to this. If you start with 4 phosphoruses and you have 1 O2, 2 O2s, 3, 4, 5 sets of O2, and they react all together, you have P4O10. This is 10 oxygens right here. See the idea of the 10 oxygens at the beginning results in 10 at the end because this is 5 O2s in order to make 10 oxygens to start with and 10 oxygens to finish with. All right, moving on to other examples. Consider this example. If you're going to start with 1 lead, okay, end with 1 lead, not a problem. Start with 1 silver, end with 1 silver, not a problem. Now look at this. 1 nitrogen, 2 nitrogens, 6 oxygens, 3 oxygens. Notice that this is the polyatomic ion nitrate. Don't try to break up the polyatomic ion if you see the polyatomic ion on both sides. Instead, leave it intact. If this is an NO3 nitrate, then this is also nitrate. And notice there's 2 nitrates here and 1 nitrate here. That's not good. So if I put a 2 here, this 2 means I've got 2 of the entire nitrate thing. By putting this 2 here, I have 2 silvers and 2 nitrates as well. So now I have 2 nitrates and 2 nitrates. But having 2 silvers, I should also have 2 silvers here, which I now do. That's going to be 1 lead, 2 silver, 2 nitrates, and now this is properly balanced. Onward, let's look at some other examples. What if I have something like this? I have oxygen in 3 different molecules, lithium, hydrogen. Okay, that looks complicated. So especially, like, notice there's oxygen in each one. If I change the oxygens on any of them, that makes it complicated. So I'm going to save that for later. I'm going to start simple. I notice lithium is just here and here, and there's 2 and 1. So I'm going to start with the simplest things first. More complex ones like hydrogen, oxygen, whatever, I'll say that, especially oxygen, I'll say that for the last one because complex ones can wait till the end. So 2 lithiums, I'm going to put a 2 here. That way it's 2 lithiums. Now we have 2 lithium, 2 lithium. Now hydrogen. Notice that there's 2 hydrogen. There was just 1 hydrogen, but now I put this 2 here. There's 2 hydrogens. So wow, that problem was actually just solved. By fixing the lithium, I also accidentally fixed the hydrogen. That's nice. Now, next thing, how many oxygens do I have on each side? This is 1 oxygen. Here's 1 more oxygen. This is a total of 2. Here, there's a total of 2. So actually, it's done. By fixing one thing, I fixed them all. That can happen sometimes. So let's look at some other examples. Okay, here. Notice we got hydrogen and hydrogen. Those aren't the same numbers. That needs to be fixed. Sulfur and sulfur. Okay, that's all right. Chlorine. Okay, so we got multiple things that need to be fixed. So we're going to do the same thing. If there's 2 hydrogens, I'm just starting on with the first one on the left because why not if it's all kind of the same. So I'll just start with this one on the left. Hydrogen and hydrogen. Okay, 2. And now it's the same number of hydrogens. There's 2 HCl's. Which, by the way, look, 2 chlorines. Now there's also 2 chlorines on this side too. So by fixing one, also fix the other. Now for the sulfur, there's 1 sulfur here, 1 sulfur here. No problem. Good, we're done. Cool, onward. What about this one? Now this one, what I'm going to notice is that, for example, see these pure elements here? The pure elements are easy to adjust at the end. Hydrogen's a pure element, zinc is a pure element. So you know what? Let's save the pure elements for last. Let's start with something simpler. So since hydrogen is not going to be done first, zinc's not going to be done first, what's that left to work on? Not hydrogen, not zinc, just this phosphate here. Notice there's 2 phosphates, 1 phosphate. Because the phosphate is intact on both sides, instead of breaking up and counting phosphoruses and oxygens, we'll just count the entire phosphate molecule. So there's 2 phosphates here, 1 here. So I put a 2, and that fixes the phosphate. Now I'm going to do the hydrogen and zinc. And since I just put a 2 here, now I'm thinking about hydrogen. Okay, I guess I might as well do hydrogen. 2 times 3 is 6 hydrogen, which means I should have 6 hydrogen here too. What do I put here to make it 6? Easy. 3. So now I've got 6 hydrogen, 2 phosphate, 2 phosphate. Now I need to deal with the last one. Haven't dealt with zinc yet. See those 3 zincs? No problem. Put a 3 here. Now you have 3 zincs and 3 zincs. Now we can check, make sure 3 zinc, 6 hydrogen, 2 phosphate, and 2 phosphate. Cool, it's balanced. Next, here, no pure element, all right. Well, let's see, what's simpler? It all looks about the same. So you know what, I'll just do barium because it's first. Why not? Okay, 3 bariums, let's make it 3. All right, cool, 3 bariums, that makes 6 bromines. All right, if I need 6 bromines, I'll put a 6 here. Oh, just did bromine. Now let's do hydrogen, since I'm on that topic. 6 hydrogens, what do I need for that? I need to put a 2 right here in order to make this 6 hydrogens. Now, having fixed that, now I got 2 phosphoruses. Do I have 2 phosphoruses here? Yes, I do. Hey, wow, I'm done. 3 barium, 6 bromine, 6 bromine, 6 hydrogen, 2 phosphoruses, or 2 phosphates, 2 phosphates. This is balanced. Let's straighten that out. There we go. Okay. Next consideration. How about this one? This is benzene, by the way. So what about all these? Well, remember, pure elements save for last. So I'm not going to do oxygen first. Guess I'll do carbon because carbon's first. No, it doesn't really matter. Could do hydrogen first, but I'll do carbon. Okay, 6 carbons. Let's put a 6 here to have 6 carbons. And 6 hydrogens. Okay, 6 hydrogen. Well, let's make that a 3. That way it's also 6 hydrogen. All right, now we need to deal with the oxygen. So how many oxygens are here? Well, 6 times 2 is 12 oxygen. And then here, 3 times 1 is 3 oxygens. That adds up to 15 oxygens. Okay, well, how are you going to deal with that? This is where the idea of the fractional coefficient comes into play. You need 15 oxygens. Someone put 15 here. But do you see that 2 right there? I put that there to mean 15 halves. 15 halves is equal to 7.5. If you have 7.5 oxygens, that's equal to 15 oxygens. So this would give you 15 oxygens on this side, 15 oxygens on this side. But wait, you can't have a fraction for a coefficient. That's not allowed. How do you solve that? Easy. You're just going to times everything by 2. When you times it all by 2, 1 times 2 is 2. 15 halves times 2 is just 15. Let's clean that up. 6 times 2 is 12. And then 3 times 2 is 6. And I'll get these notations out of the way. You don't need those at the moment. Having done that, let's check. Did that work? 2 times 6 is 12 carbon, 12 carbon. 2 times 6 is 12 hydrogen, 12 hydrogen. 15 times 2 is 30 oxygens. Do I have 30 oxygens on both sides? Well, 12 times 2 is 24 oxygen. 6 times 1 is 6 oxygen, which equals 30 oxygen atoms. Yes, it is successful. I've checked all the elements and they all balance. There's correct number on each side. This is done. Next, what about this one? So how do you balance this? Again, pure element save for last. So onward to these other ones. 12 carbon, okay, cool, 12 carbon. 26 hydrogen, okay. Well, what's going to make 26? Turns out 13 times 2 is 26. So now you have 12 carbon on each side, 26 hydrogen on each side. All right, now we deal with the oxygen. So what is it going to be for the oxygen? Well, 12 times 2 is 24 oxygen. 13 times 1 is 13 oxygens. So 24 and 13 is 37 oxygen. So I need to get 37 oxygens over here. How do you get 37 oxygens when you have an O2? Simple. Take the number that you need, make a fraction, see the subscript, put it on bottom of the fraction. 37 halves. So 37 divided by 2, by the way, is 18.5. And if you have 18.5 O2s, that's 18 O2s plus half of an O2, which is just an O, which 18.5 times 2 equals 37 oxygens. So as it's written right now, that's 37 oxygen atoms. And this is also 37 oxygen atoms. It's fully balanced. Once again, you're not allowed to have a fraction in that coefficient. So you're going to fix that by timesing the entire equation by what's on the bottom of the fraction by 2. And that should give a whole number. This times 2 is 2. This times 2 is 37. This times 2 is 24. And this times 2 will be 26. So 24 and 26. All right. Checking. 24 carbon, 24 carbon. 2 times 26 is 52 hydrogen, 52 hydrogen. 37 times 2 is 74 oxygen. 24 times 2 would be 48 oxygens now. 26 oxygens. And it turns out that 48 plus 26 is 72. So you have 72 on each side, 72 oxygens on each side. This balances, and it cannot be reduced. So we're good. Next. Here, you have oxygen to save for last. So we'll do carbon first, because why not? So 1 carbon, 1 carbon. Well, that's easy enough. What about hydrogen? Don't fall for this. Look at that. 4 hydrogens. So we got to put a 2 here. That way it's 4 hydrogens and 4 hydrogens. So having the carbon balanced and the hydrogen balanced, now for the oxygen. We have on this side 2 oxygens, and here we have 2 oxygens. Now someone might be tempted to be like, oh, I'll just put a 2 here and that's 4 oxygen and 4 oxygen, but don't forget there's 1 here also. You have a total of 3 oxygens on this side. So that's 3 oxygens here, 4 oxygens here. If you were to put a 2 here, now it would be 5 oxygens total because of this. And 5 does not balance with 4. So how do you deal with that? Well, let's do something simple. We're going to say, well, that's annoying. I've got 4 oxygens on this side. I've got 3 oxygens on this side. What could I do to give myself the amount that I need? Now, I could put a 2 here, but now I just doubled the number of hydrogens, which means I need to double this, which means I change this, which means I need to change this again, and then you find yourself going in an endless loop. So let's not do that. Let's say, I have 3 oxygens so far. It would be really nice if I had 1 more. How could I add 1 more oxygen? Simple. I'll add 1.5 of these. If I could have 1.5 of these, that'd be 3 oxygen atoms. 3 plus 1 more would be 4. So that would be 4 oxygens and 4 oxygens. Alternatively, what's another way I could write this? I could write the same idea by saying 3 halves, because 3 halves is the same as 1.5. Okay, so again, this is because it'd be nice to have 4. So if I had 3 plus 1, that would be 4. And I'll make it a fraction, though, because this is O2, not O. So that's another way to look at it. But regardless, This now gives me 1.5 of these is 3 oxygens, plus 1 more is 4, so it's 4 oxygens, 1 carbon, 1 carbon, 4 hydrogen, 4 hydrogen. It's balanced, but you can't have this in a final answer. So guess what we're going to do? Once again, when you get a fraction, or if you're just not sure, start times it by 2. And if times it by 2 gives whole numbers, go with it. And if not, try times it by 3. And if that doesn't work, give you whole numbers, try times it by 4 and keep going until you got whole numbers. In this case, I'm going to times by 2 because I know times it by 2 will give it whole numbers. Times this one by 2 and times this one by 2 and times this one by 2, and we'll multiply this one by 2. Does that work? Let's check. 2 carbon, 2 carbon. This is 4 hydrogens, so 4 times 2 is 8 hydrogen. 8 hydrogen. Let's see, this is 2 oxygen. This is 6 oxygen. So this is 8 oxygen total. This is 4 oxygen right here, plus 4 more. This is also 8. So we've got a working equation. Everything's in the same amounts. Okay, onward. Guess what? Pure element saved for last. So let's do potassium. Oh, look, potassium's already balanced. Oh, we have nitrate, NO3, but oh, it broke up. All right, well, we don't get to count units of NO3. We got to count the individual nitrogens and oxygens. So potassium, 1 potassium, cool. 1 nitrogen, cool. Oh, I guess we do have to deal with the oxygen first. How do we deal with that? There's 3 here, and 3 plus 2 is 4. Well, that's annoying. I got 4 over here and 3 here. So the way you handle that is be like, well, I sure wish this was just an O. Imagine if this was just oxygen, O instead of O2. Then you'd have 3 and 3 and it'd be perfect. So I'd be like, you know what? I'm going to do that. I wish I just had 1 oxygen. But since there's 2 of them, I'll put that 2 on the bottom of a fraction. Half of an O2, in other words. Half of an O2 is just 1 oxygen. 1 oxygen plus this makes 3. Look, we fixed it. 1 potassium, 1 nitrogen, 3 oxygen, and this would be 3 oxygen because 1 oxygen plus 2 more for 3. Well, can't have this in the final answer, so I'm going to do what I always do. Times it by 2, and if 2 doesn't give you full answers all the way across, like whole number answers, then try times it by 3. If that doesn't give whole number answers, try times it by 4, etc. Or another shortcut is, see that fraction? Whatever number is on the bottom of the fraction, times it by that. 2 is on the bottom, and times it by 2. Times 2, times 2, and half times 2 is just 1. So my final balanced equation is this. How do I know? Because 2 potassium, 2 potassium, 2 nitrogen, 2 nitrogen. This is 6 oxygen. This is 4 plus 2 more is 6. So we have 6 oxygen and 6 oxygen. All right, onward. Aluminum, hydrogen, chlorine, Well, that's a pure element. I'll say that for last. That's also pure element. I'll say that for last. Well, chlorine it is, I guess. 3 chlorines. Let's times it by 3. All right, we got 3 chlorine, 3 chlorine. 3 hydrogens. Oh, well, okay. I need 3 hydrogens on this side. It's a molecule with 2. So 3 halves. If I had that, it would be 3 hydrogens. Well, that'll solve that temporarily. And as for aluminum, that's good. 1 aluminum, 3 hydrogen, 3 hydrogen. 3 chlorine, 3 chlorine. Once again, you can't have a fraction. So let's times it all by 2 and see if that gives whole numbers. If that doesn't work, try times it by 3. If that doesn't work, try times it by 4. If that doesn't work, try times it by 5, etc. Or alternatively, you can think of it as there's a fraction, 2's on the bottom. Cool, let's multiply by what's on the bottom of the fraction, which means times it all by 2. 1 times 2 is 2. 3 times 2 is 6. You know what, that looks ugly. I'll white it out. Times 2. And 3 halves times 2 is just 3. Let's double check that. 2 aluminum, 2 aluminum. 6 hydrogen, 6 hydrogen. 6 chlorine, 6 chlorine. Yep, it's good. All right, onward then. Okay. Let's straighten that out a bit. Looks slightly better. All right, oh, close enough. Okay. Save the pure element for last. I guess we're doing carbon first. Oh, but carbon's good. Well, back to the pure element again. All right, 3 oxygens, 2 oxygens. Man, I wish I only had 1 oxygen here because then it'd be just 2 oxygens and 2 oxygens. But it's a diatomic element, So I got to put it as a fraction. Half of an O2 means just O. So O plus O makes 2 oxygens and 2 oxygens. Yay, that's good, except you can't have a fraction for your final answer. So it either times by 2 and then 3 and then 4 and then 5. Like times by the number that makes everything can be a whole number, and times it by 2 works. If it didn't work, I'd try 3, and if 3 didn't work, I'd try 4. But times it by 2 would turn all these into whole numbers, or alternatively, look at the number on bottom of the fraction. Times by the number on bottom of the fraction, and that should make everything whole. So that 2, I'm going to times it by 2, and times everything else, multiply everything else by 2 as well, which means there's going to be just 1 oxygen now, and there's going to be 2 of these, which means 2 carbon, 2 carbon. Let's see, 2 oxygens, 3, 4 oxygens, so 4 oxygens, and oh look, 4 oxygens. So 2 carbons, 4 oxygens, it's balanced. All right, onward to the next thing. All right, lead and lead, oh that's good. Nitrate and nitrate, oh not good. We need 2 of these. That way it's 2 nitrates, 2 nitrates. Okay, now let's try sodium. 2 sodiums, oh, gotta have a 2 here. That's 2 sodium, 2 sodium. Now what about that chlorine? Oh, we do have 2 chlorines. Yay, look, balanced. 1 lead, 2 nitrates, 2 nitrates, 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. All right, onward. What about this one? Well, we'll save the pure element for last, and then we will carbon first, I guess, because it's the first. There's no real good reason. All right, 6 carbon. Let's put a 6 here. Make it 6 carbon. Oxygen. Save that for last. It's the pure element. Hydrogen. I'll put a 6 here. That way it's 12 hydrogen and 12 hydrogen. All right, now I'll have to deal with the oxygen. What have I got so far? I have 6 times 2 is 12 oxygen, and then 6 times 1 is 6 oxygen. So that is 18 oxygens. I better have 18. Well, look here. I need 18 oxygens. I've got 6 so far, equals I need 12 oxygens more. So I'll just put a 6 here. That way it's 12 oxygens more. Did that work? Let's see. 6 carbon, 6 carbon. 12 hydrogen, 12 hydrogen. And finally, 12 plus 6 is 18 oxygen. 6 plus 12 is 18 oxygen. 18 and 18. All right, that works. This is photosynthesis, by the way. All right, onward. Well, we'll save this for the end. Pure element right there. And we'll do carbon first, but I see carbon's already balanced. Okay, hydrogen next then. 4 hydrogen means I need to have 4 hydrogen here. All right, now we'll do oxygen. And I got 2 oxygen here. And this is 4 oxygens. Oh, that's nice and easy. Just put a 2 here and it's done. See, you don't need fractional coefficients every time. Sometimes it just works. Check it out. 1 carbon, 1 carbon, 4 hydrogen, 4 hydrogen, 4 oxygen, and 2 and 4 oxygen. Done. So don't start thinking that every one of these O2s needs a fractional coefficient. It just isn't always necessary. All right, now onward. Phosphorus and phosphorus. Oh, so this is phosphite and it looks like it broke up. Well, we got to count each individual atom then. No pure elements, so I guess we'll just start with phosphorus. 1 and 1. Okay, well, nothing to do there. Bromine. Oh, we get 3 bromine. Let's make that 3 bromine. 2 hydrogen. And then we got 6 hydrogen. Oh, that ain't cool. All right, well, let's go ahead and make that times it by 3. So now it's 6 hydrogen, and this is 3 plus 3 is 6 hydrogen. Okay, that's good. 3 oxygen. Oh, 3 oxygen. Look, that's fixed. Fair enough. Okay, 1 phosphorus, 1 phosphorus, 3 bromine, 3 bromine, 6 hydrogen, and between these it's 6 hydrogen, and finally 3 oxygen, 3 oxygen. Cool, that's good. Onward. Aluminum. Yeah, let's say that for last, it's a pure element. Iron. Yeah, let's say it for last, it's a pure element. All right, just oxygen. Now we need to figure out how to get the same number of oxygens when you have 4 and 3. Here's a nice little shortcut when you have this situation, when you got different subscripts, and it's only into these 2 locations. Let's do what I call switching the subscripts. See this 3? Put this over here. See this 4? Put it over here. Now you've got 3 times 4 equals 12 oxygen, and 4 times 3, aka 3 times 4, is 12 oxygen. Ah, 12 oxygen, 12 oxygen. And all we did was put this 3 here and put this 4 here. That balanced the oxygens. Now I can deal with the rest. 4 times 2 is 8 aluminum, so I'll put an 8 here. And then 3 times 3 is 9 irons, so I'll put a 9 right there. And 8 aluminum, 9 irons, 12 oxygen, it's done. Onward then. What do we have here? Sodium. Okay. No pure element to deal with. Okay, sure, let's start simple. 2 sodiums. And being that we now have 2 sodiums and 2 sodiums, let's look at the rest. Okay, the hydrogen. We now have 2 hydrogen. Okay, so by fixing the sodium, we also fix the hydrogen. Now, what about the carbon? That's 2 carbons. Guess better fix that. 2 carbon. Now, the oxygen. What did we do? We have 2 times 3 is 6 oxygens. So we have 6 oxygens to start with. And then 1, 2, and this is 4 oxygens right here, so 4. And then plus these other 2 make 6. So actually, there's 6 oxygens, and there's 6 oxygens here as well. It's done. That oxygen would have been complicated to do as the first thing, and that's why if it's complicated, leave it for last, because by fixing the other things, oftentimes you wind up fixing the complicated thing without even realizing it. All right, on to number 19 here. Let's move this up so it's easier for the viewer to see. Sodium. Save the pure element for last. Same for hydrogen, which means, what's that leave? That leaves oxygen. But, oxygen's already balanced. All right, well, I guess we have to do the others. 1 sodium, 2 hydrogen. What's this? We call this balanced as written, where nothing is needed. And that'll work just fine. So, all right, all good there. Sorry, my mistake. I just realized right as I said that, I was like, oh, that's not right. Why did I say that's not right? Well, 1 sodium, that's good. 1 oxygen, that's good. But 2 hydrogens, this is 3 hydrogens. Whoops. Okay. So, what do? Well, once again, be like, 2 hydrogens, 3 hydrogens. Well, if this was just H, we wouldn't have a problem. So I wish we had half of this. Wish there was just 1 hydrogen here and not 2. But it's a diatomic element, and there's 2 in that subscript, so I'll put it like this, half a hydrogen. But that's where this comes from. 1 because that's how many I wish I had, and this because that's the subscript. So if this was true, now I'd be like, all right, well, we have 2 hydrogens and 2 hydrogens with half of an H2. But since you can't have a fraction in the final answer, we're going to times the whole thing by 2, and multiplying the entire thing by 2 gives 2 sodiums, 2 waters, 2 sodium hydroxides, but just 1 H2. Let's kind of fix that hydrogen right there. All right, anyway, that's 2 sodium, 4 hydrogen. This is 2 plus 2 more, so this is 4 hydrogen, 2 oxygen. Okay, so now that's fixed. Next thing, PBS. Well, not bad. Okay, we'll save the oxygen for last because it's the pure element. And then lead first, but nothing needs to be done. Okay, fair enough. Sulfur. Oh, but nothing needs to be done. Well, guess we are dealing with oxygen. And once again, we got 3 on this side, 2 on this side. I'll handle it the same way I've been handling it, which is, there's 3 here. I sure wish we had 3 over here. Yep, I sure do. Put the number you wish for on top. See this coefficient? Put that on the bottom. 3 halves. 1 is the same thing as 1 1/2. If you had 1 1/2 oxygens, that'd be 3 oxygen atoms to balance these. And as nice as that would be, you can't have that for your final answer. So you got to times the whole thing, multiply the entire equation by 2. So this times 2 gives that, and then 3 halves times 2 is just 3. And then times 2 and times 2, because what you got to do to one, you got to do to all of them. So they all got multiplied by 2. Now we have 2 leads, 2 sulfur. This is 6 oxygen. 2 plus 4 is, 6 oxygen. And that completes it. A full set of examples for balancing chemical equations. All right, happy studies.